Hello everyone, welcome to the fourth tutorial video that we'll be doing with respect to what we started, um, the concept of programming language, implementing it with Python. First and foremost, let me apologize for the abrupt end then of the third tutorial video. I had some technical issues, so I'm very sorry for that. However, today we'll be continuing from where we stopped at the third tutorial video. At the third tutorial video, we were able to establish the understanding of arithmetic operators, and we also looked at examples. We also looked at and identified compound arithmetic operators, and we also looked at examples too. Today we'll be looking at or identifying relational operators and relational compound operators and logical operators. That is what we'll be looking at today: relational operators, relational compound operators, logical operators. Okay, but before we delve into that, I would like to draw our attention to an aspect of arithmetic operators operation. We are going to look at briefly what is order of precedence when it comes to evaluation of expressions. Okay, that is another key concept that has to be explored in course of our tutorial. Order of precedence, simply in mathematics, is the way an expression will be evaluated. Okay, so I have several examples here on Python, which I have stated earlier on. Because of time, the videos are getting longer, so I have to do this before the commencement of the video. Okay, so if we have this expression that we are looking at here, which is highlighted, the identifier x is assigned the following expression. So we have 4, 2, integer 9, 15, and 5. Now, how would this expression on the right hand side of this statement, this is a statement in Python rather, okay, so how would this right hand side be evaluated? How would the calculation be done? That is what we are looking at. Now, in order of precedence in mathematics, which also programming languages, arithmetic operators adopts as well, it's this: multiplication operator and division operator are of the same precedence. That's their level are the same, while addition operator and subtraction operators are of the same what precedence. That is, they are of the same level. Okay, but multiplication operator and division operator, they are higher than addition operator and subtraction operator. That is to say, in the order of precedence, multiplication and division operators are senior to addition operator and subtraction operator. So when we talk about precedence, we are talking about seniority in our own local parlance. Okay, if you're in a family, you know the firstborn has some rights and privileges. okay, over the second son, or the second born over the third born, as the case may be, right? So use that concept when we talk about operators. Okay, we are using that concept in seniority in a family to apply in mathematics, just an analogy. Okay, so what we are saying is that multiplication and division, they are of the same level. Okay, whichever one that comes first, whichever one that is first in terms of execution, because the program, this expression is evaluated from left down to right. Okay, so it means that since multiplication operator it's higher than multiplication operator and division operators are higher than addition operator and subtraction operator, it means that the processor will first of all, since it's from executing from left to right, is going to run through the expression rather. It will first of all run through the expression and look in order to get the order of precedence. Okay, who is senior in this the operators that are used or that are found in the expression, who is senior. And when it encounters multiplication, okay, it's going to first of all look at the operands that multiplication operator is between. So it will first of all evaluate 9 times 15. Okay, when it gets that result, it stores it, then it runs through again to find out the seniority in the operators. Then it's going to execute now the result of 9 times 15 with 5. Okay, after it has done that, it's also going to run through again to look for who is senior amongst the operator. Then it's going to, the result that has been evaluated on these three expression will now be evaluated, will now this, so it's going to run through, and we discover now that both addition operator and subtraction operator are of the same level, but since the execution is starting from the left, so it's going to first of all attend to 4 and 2. So it will add 4 to 2, and the result would be subtracted from this order, the result that was gotten from this. So let's look at the order of precedence here as I explained it. So this is the expression we have there on the Python interpreter. So I'm saying here, what we are saying, the concept of order of precedence is that 9, since multiplication is higher than addition and subtraction, and multiplication here is before division, so the interpreter, the processor, will first of all evaluate this. So when that will be the first evaluation, so it will do 9 times 15, the result will be what? 135. Now it's going to look again through the operators. Now we discover that division, it's also higher than addition and subtraction. Okay, so it's going to evaluate this, the result of this, and 5, division of 5. So the second evaluation now will be 135 divided by 5, will have what? 27. So the whole of these three expressions here will give us what? 27. Now we have handled this aspect. It will then come to this, it will then come to the beginning again, looking for order of seniority or order of precedence as the case may be. addition is higher than addition and subtraction are of the same level, okay, but who it meets first in the evaluation of the expression, that is from left to right, it will first of all evaluate what? Addition. So what we will then have here will be 4 plus 2. That will be the third evaluation step, okay. So 4 plus 2 will give us what? 6, okay. So what we will be left with now will be subtraction, okay. So the fourth evaluation step will now be 6 minus 21, because the whole of this evaluation here gave us 21, while this evaluation gave us what? 6. So 6 minus 21 will minus 27 rather. 6 minus 27, which we got here, it's going to give us what? Minus 21. That is the final answer. And if we go back to our program and we run this, we'll discover, let me just run it so that you see what we'll discover here, that minus 21 is the result, okay. It comes out in floating point because of this division here, or this division here, as the case may be, as we've seen, okay. So minus 21. So if we come down a little bit here on the display, we discover here I decided to print this on one line each, and I also printed this on one row each, and I also printed it on one line, one row, all the answer on one row. So we could see here that this capital X here is what? X is equal to what? Minus 21. Okay, so that is the order of precedence. Okay, it's about identifying the seniority in operators in an expression. Okay, so division and multiplication are of the same precedence. Okay, while addition and subtraction are of what? The same precedence. However, division and multiplication are higher, they have higher precedence than addition operator and subtraction operator. So since division and multiplication are of the same level, as the execution is spanning from the left to the right, if it meets division first, it will do division. It's going to evaluate both operands that are found on the left and right hand side of the division. If it meets multiplication first, it's going to evaluate the operands on the left and right hand side of the operator multiplication. Whatever the result is, then it will look again for order of precedence. All right, whatever operator it's found and it gets the order of precedence, it's going to evaluate. So order of precedence is key. Now if you want to change, if you want to influence the result as it is now, you discover that the result here is that we got in capital X is what? Minus 21. However, if we go to X2, capital X2, we'll discover that with the use of bracket, we've been able to what? Influence the result. Okay, X2, when it evaluates, we have what? 17, minus 17 as the answer, okay, or as a result, as you can see here, while X initially gave us what? Minus 21. Now minus 21, the first expression, we allowed the interpreter and the processor to do the evaluation. Now on the second expression, we are now forcing, there is a particular result we want to achieve, So we introduce the bracket. Okay, now the bracket now influence the order of what? Execution. Now with this bracket, what we are telling the interpreter and the processor to do is that first and foremost, when you encounter a bracket, whatever is found in that bracket in an expression, okay, that should be evaluated first, irrespective of the operators that is found there. That should be evaluated first, and whatever operators that is found in that bracket, you can also apply the order of precedence as well. Okay, I'll take that again. Now with the introduction of the brackets that we're seeing here, okay, we are now forcing the execution order. We are changing it. Okay, so that is to tell you that when you introduce a bracket now has a higher precedence over the operators. Okay, bracket now has what? A higher precedence over the operators. So whatever expression is found in that bracket, what we are telling the interpreter and the processor is start your evaluation, start your order of precedence in that bracket. So if we have plus and minus here in this bracket, it will also apply, it will first of all come into this bracket to look for order of precedence. But since there is no order, there is only one operator here, so it's going to evaluate 2 and 9. So what we'll have here now is 2 minus 9 will give us what? Minus 7. Okay, now minus 7 will be kept here. We'll have minus 7. The next thing that will happen, since it's evaluating from left to right, it will then do 7 times 15. 7. Let's look at our calculator here. So we'll have 2 minus 9 will give us what? Minus 7. Okay, now minus 7, it will now be minus 7, it will now be minus 7 times 15, 105. Okay, so minus 7 times 15 will give us what? 105. 105 divided by 5 will give us minus 21, right? Minus 21 plus 4, that is 17, and this is minus 17, and this is the minus 17. So with the introduction of bracket, which has a higher precedence over every other operator, we've been able to what? Influence the outcome of the result of the operation. Right now we see it's still the same expression, 4 plus 2 minus 9 times 15 divided by 5. Okay, then it's still the same thing here. However, with the introduction of this bracket, we've been able to what? To change the way the processor and the interpreter will evaluate the expression, and we have what? Minus 17. If we look at the second expression, the third expression, x3, is the same thing. We introduced a bracket here. So what happened here is the evaluation process will start within this bracket. Now evaluation starts from left to right. Okay, so we have plus and minus having the same what? The same order of what? Precedence. They are of the same level. But however, since plus is before minus, is going to evaluate 4 plus, is going to evaluate in the order 4 plus 2 will give us 6. 6 minus 9 will give us minus what? 3. Now, minus 3 times 15 will give us 45. Then, minus 45 divided by 5 will give us what? Minus 9. And that is what we have here. Okay? Are we seeing it? Now, if we look at x4, the expression x4 here, we discover that with the introduction of bracket here, it still didn't make any difference with the first one. Okay? With this expression x. Now, let's look at the evaluation process. We are telling the processor and the interpreter that first and foremost, evaluate 4 plus 2. It will evaluate it as what? 6. Okay? Then, if it goes through it again and it looks for order of precedence, it discover that it's 9. It will now evaluate 9 multiplied by 15 will give us minus 135. Okay? Minus 135 divided by 5 will give us what? Minus 27. Minus 27 plus 6 will give us what? Minus 21. And that's how we arrived at this. Let's show with this calculator. We are saying that on this x4, it will be 4 plus 2. It will evaluate to what? 6. Okay? So here will now be what? 6. The result here will be 6. So we'll now have 6 minus 9. We'll now have something like this. We'll have 6 minus 9 times 15 divided by 5. Okay, that's how it's going to be. Now the next evaluation process will now be minus 9 times 15. Okay, the result will be minus 135. Okay, that will be minus 135. Okay, now it will then be, since this is taken care of, the order of precedence after multiplication we have division, so it will now be minus 135 divided by 5. It will evaluate to what? Minus 27. So minus 27 will now be 6 minus 27. It will evaluate to minus 21. Okay, it's going to evaluate to minus 21 as the case may be. So that is how it is. So you should be very careful when it comes to order of precedence. Okay, a question might come this way and you are asked to evaluate to get the difference. You discover that irrespective of where this bracket is, the result of x1 and x4 are the same, like we have here. x1 is minus 21, then x4 is minus what? 21. Okay, so this bracket is irrelevant, okay, since we are arriving at the same result. So you should be very careful when it comes to order of precedence. These things you need to walk them through, like I did here in this example, to see what the result is. Don't assume. Okay, the lecturer might decide to, or the exercise or whatever might decide to introduce brackets, and you need to go through the steps to know what the final result is. We also have another example down here. 2 plus 3 times 5. We discover that multiplication is senior to addition, right? So it will first of all evaluate 2 times 3 will give us what? 15. Then it will then evaluate 15 plus 2 plus 15 will give us what? 17, and that is the result here. Okay, now a bracket is also introduced here. Okay, Now you discover that the result will be influenced, the outcome will be influenced because of what? This addition, this added bracket. So what you're telling the interpreter and processor to do is to first of all evaluate what is in the bracket, what is found in the bracket. So we are going to have 2 plus 3 first, which is 6. Then that result will be multiplied by 5. That will give us what? 2 plus 3 is 5, rather, not 6. 2 plus 3 is 5, and 5 multiplied by 5 will give us what? 25. Okay, now we also have this. We discover here that we have multiplication, division, and modulus. Now let's see what this will evaluate to. Okay, so what this will evaluate to is modulus and multiplication and division are of the same precedence. So let's see what it will evaluate to, and we could just do a run down. If we say modulus, if we say 4 modulus 2, it will to evaluate, we are doing from left to right. Okay, so it will evaluate to what? 0, because 4 divided by 2 will have 0 remainder. Okay, modulus gives you the remainder of a division. It will be 0. So the expression now will be 3 plus 0 plus 3 multiply 4 divide 2. Okay, so that's the new result. So the next order of precedence will be 3 multiply what? 4. So we go down, 3 multiply 4 by 4, it will evaluate to what? 3 times 4 will give us 12, right? So the expression will now read 3 plus 0, 3 plus 0 plus 12 divided by 2. Okay, so the next operation will be 12 divided by 2. So if we go down, 12 divided by 2, it will evaluate to 6. Okay, so the expression will now be 3 plus 0, 3 plus 0 plus 6, right? Okay, so this will now evaluate to what? 9. So that is how the interpreter and the processor will evaluate this expression that has what? Modulus. Now we discover that modulus and multiplication and division are of what? The same what? Precedence. They have the same precedence level. So as it's checking, it's going to first of all evaluate 4 modulus 2. Okay, now if we first of all evaluate multiplication, we'll discover that the results may also change. However, but this is to inform you, if we have a different value here, say 3, then the result will be what? Definitely the result will be influenced, as the case may be. So take note of this order of precedence. It's key that we know this order of precedence in our programming language. Each time we are working with values and we are performing arithmetic operations on operands, it's key we know the order of precedence. We have the exponential, we have the bracket, we have the exponentiation. Okay, bracket has a higher precedence over exponentiation. After exponentiation is, if we want to say S6, when we talk about exponentiation, we say x6 3 star star 3. Okay, if we print this out, say x6, we'll see the result there. Exponentiation, we are saying 3 times 3 times 3. Okay, that's what this expression is. That is 3 raised to power 3. Okay, this is how it's written in Python. What do we have there? We have what? 27. So that's the result. So 3 times 3 times 3 will give us what? 27. So after bracket, in the order of precedence, we have exponentiation, we have multiplication and division, we have addition and subtraction, and so on and so forth. So that is that for order of precedence. So we will be delving now into what we have for the day, which has to do with relational operators. Relational operators. Relational operators. Now, relational operators, just like we have them in our mathematical expressions, okay? We have the less than operator, we have the greater than operator, okay? Then the less than equal is regarded as a compound relational operator. The greater than equal is also regarded as a compound relational operator. Then the double equal sign is also a compound relational operator. Then the not equal to is also regarded as a compound relational operator. So let's see how these are implemented in programming language. Basically, what you need to know is the concept of these operators, the concept, how they are being used, okay, where it will be necessary in course of your programming or designing a program where you may need these operators to evaluate, and you're looking for a particular result where you need to use these operators. Now I'm going to show you a program which I designed in C++, and you could see here, let me just pick out one where the case arose for me to use a relational operator. Okay, so we could see here how this relational compound operator. Now, first semester.creg grade, if first semester.this is less than -1, I want you to evaluate this. Okay, so the concept is you're testing whatever is in this identifier here, if it is less than or it is equal to -1, then the text box should be assigned a blank string. If it is not, then the text box, this should be assigned the grade. Okay, then here again is another example, another implementation or example, as the case may be, in the program I wrote. If whatever is contained here is greater than or equal to 1, nothing should happen. Then I said here, if whatever is here is equal to 0, okay, then a message box should be flagged off, informing the user that he is what? Successful. This is an identifier that is a string, okay. Whatever the content is, it should display it on the screen to inform the user, then subsequent operation. Okay, so it's just for you to get the concept, the idea, how it works, okay. And you might find yourself in a situation where you have to use these operators in course of your programming. Okay, so now let's look at an example here. Okay, we can say, can take off the whole of this. Okay, take off the whole of this. Can take off the whole of this because we don't need them anymore. So we can, now we know the value of x4, which is minus 21. We know the value of x, right? Good. So we can say this, print we can say if x is less than, if x is less than sorry, is my on-screen keyboard. If x is getting it. If having challenge. Okay, so we can say if x, my on-screen keyboard, my hard keyboard is having issue. If x is less than, I was clicking on the wrong key. If x is less than S4, capital S4, okay, we have to indent this. We have to indent this, print yes, the string yes, okay. So if we evaluate this, if this evaluates and yes is printed, it then means that by the time the content of x and x4 were compared, okay, it discovered that x was less than what? X4. So let's execute this and see if we are going to see this, if we are going to see yes on our display here. Okay, so we didn't get anything. It then means x is not less than what? X4. We can as well turn this the other way around. We know the value of x, right? We know the result of x. Let's also print their results so that we can we don't get ourselves confused, x is equal this, comma, then x4 equals x4 equals x4. Okay, so I'll pull this one out. Okay, so this statement only satisfies this. If this is printed out, we will discover that I just wanted to output this result here for us to see that x is, to see what the result will be. So we didn't have x printed as yes, so this condition did not satisfy for this yes to be printed. However, we are seeing that x is equal to minus 21.0 and x4 is also equal to what? Minus 21.0. So the yes will not be printed out. Okay, so x is not less than x4. Are we together? We discover here that both are of what? They are having the same what? Result. Okay, so we can as well change this sign to greater than sign. Okay, so we'll say greater than. If the content of the identifier x is greater than the content of the identifier x4, yes should be printed out. Okay, then whatever x is should be printed, whatever x4 should be printed. Okay, but if this condition is not true, then yes will not be printed out. Okay, that is what the idea I want to push forward. So yes is not printed out. Okay, but we discover that x is still minus 21 and x4 is still minus what? 21. Okay, so let's change this to minus 2 to x2 now, and when we evaluated x2, we discover that x2 is less than what? It's x2 is minus 17. So now the question is, if we turn it the other way around again, we are saying we want to test if x2 is less than x4. If x2 is less than x4, if the identifier x2 is holding a value that is less than the identifier x4, yes should be printed out. Okay, and the content of those two identifiers should also what? Be printed out. But if it is not, yes will not be printed out. Okay, so let's run it. Is minus x2 less than minus x4? So it evaluated to what? So we discover that minus x2 is not less than minus s4. So let's change the operator to greater than operator. Use my on-screen keyboard again. Okay, so we want to confirm with this expression here, is the content of identifier x2 greater than the content of identifier x4. If it is greater, then yes should be printed out, then both contents should also be displayed independently. Irrespective of this condition, this statement will still print. Okay, wow. So we could now see that x has been what? Printed. Now this statement here is attached to this if statement. Okay, this print yes is attached to this if statement because it is what? Indented. Okay, that tells the compiler, the interpreter, the Python interpreter knows that this statement print yes is attached to this if statement, because that is the syntax for if in how to write an if statement in Python. Okay, so we could now see that yes, minus 17 is greater than what? Minus 21. It's a simple mathematics. Everything on the left hand side is imaginary, and everything on the left hand side is imaginary. If you look at your number, listen, you discover that you have minus 1 is greater than minus 2, minus 2 is greater than minus 3, minus 3 is greater than minus 4. So minus 17 on the line will be greater than what? Minus what? Minus 21. Okay, so that is the concept of the greater than and less than operator. Now we'll be looking at the compound greater than equals what? Operator. Okay, so we'll change this now to, let me introduce my screen keyboard again. Now what we are saying here is if the content, will change this again to x, so we are saying if the content of x is less than or equal to this, yes should be printed. The statement comes in 2. I'll give you this way. If x is less than x4 or x is as equal x4, that is what this statement is all about. So it will check for 2 conditions. Okay, it's going to check, is the identifier x, its content, is it less than x4, or if it is not less than x4, it's also going to check, is the identifier x, is it equals to s4, what x4 is holding. If yes, then it's going to print yes. But if both conditions are not satisfied, then it's going to print what? It won't print x at all. So let's look at it. We'll get to that. We could see the use of logical operator there. We'll visit that much later, so let me keep that. So let's look at it again. Let's see what it's going to evaluate to. Save. Now note, x, we already know x to be minus 21, we already know x to be this. Okay, so, and I explained the concept of what I have interpreted what this compound operator is. It has 2 sides to the expression. Okay, so let's see what the result will be. Good. So we have x here, we have yes printed out. Then we discover that X, let me bring up this again. We discover here that X is not less than 20, X is not less than X4. However, X is equal to what? X4. So this condition was satisfied. That was why yes was printed. Now, this condition was not satisfied, which is for this part, but this other part, the equal sign, this was satisfied, which is this. Okay, so we have two operators in one statement, in one operator. So that is why it is called a compound what? Operator. Okay, so either if it evaluates to true either of the conditions, it's going to print yes. But if either of the conditions are not met, it won't print yes. Let's look at the other scenario of this. Okay, so we are going to change this now to, we'll just move this to this. Okay, we have to change this. Call up my on-screen keyboard, and we look at it again. Now we've changed this to greater than or equal to. Now what this is saying as well is, explain, it also has two parts. Okay, it's going to evaluate, is the identifier X content greater than the identifier X4 content, or is the identifier X content equal to the identifier X4 content. Okay, if either of them returns true, yes will also be printed out. So we'll take this off, put it down here, then we carry out our evaluation. Yes. Okay, so what this simply means is that while yes was printed out, it's because this other part of the condition was not satisfied, but this other part of the condition or evaluation was satisfied. Okay, so we know that X is equal to what? X4. That is the identifier X, the content that is holding is also equal to the identifier X4's content. Okay, so that is the concept there. Okay, 7 minutes. Okay, so we will go on to the next on our list there. We've been able to look at less than, we've been able to look at greater than operator, we've been able to look at less than or equal, less than equal to operator, we've been able to look at greater than or equal to operator. We are going to look at equals operator. Now the equals operator, it's a double assignment statement, or this double assignment statement is or equal, this double in mathematics we say, in mathematics we will say that in mathematics we'll say something like this: 2 plus 5 equals what? 8. But in programming language, particularly in Python, we are going to say, for us to look for that, we'll say, if we want to write this in Python, we'll say 3 plus 5 equals what? 8. That's what it's going to mean. Okay, so in Python, in Python language. Okay, so this statement is the same is an equivalent statement of this, but this is in mathematics. This is mathematics. Okay, in mathematics you write it this way, but in Python language it is written this way. They mean the same thing. This is an equivalent statement of this, but this is how it is written in Python. So what is saying is that by the time you add 3 plus 5, you have what? 8 is equal 8. Are we seeing the concept? 8 is equal 8. Just as you say 3 plus 5 is equal to what? 8. Okay, so but in Python, this is how it's going to be written, and this is the syntax for, or the operator for equals in Python language. Okay, so let's go. So we are going to evaluate again. If the identifier x content is equal to the identifier x4 content, print yes. Okay, we are testing to see if the answer, if the evaluation is true, if the evaluation is correct, then yes will be printed. If the evaluation is not correct, if it is not correct, then yes will not be printed. So let's look at it again and we see. Okay, so yes is printed. Now we discover that the content of the identifier x is minus 21 and the content of the identifier x4 is minus what? 21. So it satisfies the condition. Both contents of the identifiers are what? Equal. So it printed what? Yes. Okay. Now if we change this x to x2, we will discover that the yes will not be printed out, because when we did our evaluation, we discovered that x2, when let's just run the program and we'll see. We now have what? X, the content of x2, not just x, rather the content of x2, the content of x2 is minus 17 and the content of x4 is minus 21. So they are not equal to each other, right? So they are not equal. So they are not equal. Simply put, they are not equal. Okay, so I guess this is simple enough. Okay, so we've been able to see the equal sign with the examples I did here, showing you what it is in mathematics and what it is in Python programming language. Okay, so the next one we need to look at is not equal operator, not equal compound operator, and it is written as this. Call up my screen keyboard. So we want to see how this compound not equal operator, how it works. So what we have here is whatever is on the right operand or right hand side of the operator should be compared with whatever is on the right hand side of the operator, not equal. Okay, if the results at the end of the evaluation returns true, yes will be printed out. But if the result returns false, yes would not be printed out. Then the content of x2 and x4 will be printed out as well. So let us see. Okay, so we discover that yes is printed out. That is to say, the content of the identifier x2 is not equal to the content of the identifier x4. So we could see that x2 is minus 17 while x4 is minus 21. So if we change this to x, okay, and we know that x here will give us what? Minus 21, and x4 will also give us minus 21. So let's see if yes will be printed out as well. Okay, so yes was not printed out. Initially, yes was printed out, but on changing it, we discover that this statement here, the if statement here, returned what? False. That is to say, what is the identifier x, what identifier x is holding is actually equal to what the identifier x4 is holding. So both of them are equal. Okay, that is why the yes was not printed out. Now, another situation where, or scenario where you can actually use this relational operators. You could use them maybe in grading. Okay, if you want to discover, if you want to find out what the score a student got vis-a-vis the grade, okay, you could also, that's one area where you can easily implement the use of these operators. Okay, that's a key area where you can implement this as well. Okay, so our next port of call will be the logical operators. There are basically 3 logical operators in Python, okay, that we'll be considering. We have the AND operator, we have the OR operator, we have the NOR operator. Okay, so we'll be looking at how the concept behind these operators. Now, usually when we talk about logical operators, we usually reference what is called a truth table. Okay, a truth table is a table that gives you the possible combinations of events and their logical outcome, as the case may be. So we have a truth table, we have the AND truth table. Okay, now open your mind with respect to this and just get the basic concept behind the truth table, the AND truth table. The AND is an operator. Okay, the AND is an operator. Now, it is used to evaluate 2 possible conditions. So here we have T, which, as I've stated here, the key is T is truth, F is what? False. Okay, so if you have 2 conditions, if you AND 2 truth, the result will be true. If you AND truth and false, the result will be false. If you AND false and true, the result will be false. If you AND false and false, the result will be false. If we look at this other table here, if you have the possible combinations that you can have, since we are working with base 2, the computer, the machine language is usually, it's in machine language is in 1 and 2, which is in mathematics is base 2. We know, if we remember, for those of us that did mathematics, we have base 2 number system, we have base 10 number system, which is the one we use in counting. From 0 to 9 is base 10. We have base 8 number system, that is from 0 to 7. Then we have the base 16, which is from 0 to F, as the case may be. We may not be able to delve into that, but note that in a base 2 number system, the highest value you can get there is 1, and the lowest value you can get there is 0. So it's between 0 and 1. So we'll look at the possible combinations of 0 and 1. That is how this truth table was derived. Okay, so the possible combinations of 0 and 1 is 0 and 1 and 1 will give you 1. 1 and 0 will give you what? 0. Then you flip their positions. You bring this 0 to the right hand side, okay, and you bring this 1 to, you bring this 0 to the left hand side, you bring this 1 to the right hand side. These are the possible combinations that you can have. 0 and 1 will still give you 0. Then you repeat 0 and 0 here, will still give you what? 0. Okay, so this is the truth table for the AND operator. Now, what this simply means is that the only time you're going to have a 1, or the only time you're going to have a true as the result, because this is Boolean, okay, it's when both conditions are true. When the right hand side of the AND operator is true, and when the left hand side of the AND operator is true, and the right hand side of the AND operator is also true. That is when you are going to have a true result. When the left hand side of the AND operator is true, and the left hand side of the AND operator is false, it will give you a result of false. When the left hand side of the AND operator is false and the right hand side of the AND operator is true, it's still going to give you false. When the left hand side of the AND operator is false and the right hand side of the AND operator is false, the result will give you what? False. So the only time, if you're using an AND operator, the only time it's going to evaluate to truth is when both the left hand side and the right hand side of the AND operators return what? A truth. Okay, that is when you'll be able to have a truth. The other three combinations, or the other three aspects, will return a false. So you can see here that true, then you have false, false, false. You have 1, you have 0, 0, 0. Okay, now for you to better understand this, if you have, for the AND operator, which is a logical operator, acts as if it is a multiplication operator in mathematics. Okay, now you know that in mathematics 1 times 1 will give you 1, right? 1 times 0 will give you what? 0. 0 times 1 will give you what? 0. 0 times 0 will give you what? 0. This same concept is what is applicable here. Okay, you could see 1 0 0 0, 1 0 0 0. So the only time you're going to have a 1 as a result is when both conditions, both operands in between the AND operator or this multiplication operator it's what? 1 or true, as the case may be. Okay, so there are situations where this could be implemented. Now I'll give you a typical example. Let me just give you an analogy here. Like I stated, I said the Boolean could be explained with this analogy. When we talk about Boolean, we're talking about two states: the state of being a 0 or the state of being a 1, the state of being a true or the state of being a false. That's all about Boolean. Okay, if you are not sleeping, you are awake. Okay, if it is not 1, then it will be what? 0. That is Boolean. Okay, that's Boolean for you. Okay, so I have here, for instance, a light bulb. I say condition 1. The only time the bulb will light up, it's when there is electricity and switch is at on position. So if we have true, it will give us what? True, right? That is to say, if there is electricity supply and the switch with which you use to switch on the light and switch off the light, if that switch is on the on position, then the bulb in your house or in your room will what? Light up. Okay, the only time that bulb in your room will light up is when two conditions are satisfied, basically. And what are those two conditions? The first condition is that there should be electricity supply. The second condition is that the switch that is controlling the light will be on the on position. Okay, once these two conditions are satisfied, then the light switch, the light bulb in your room will what? Light up. Apart from that, any other condition put together will always mean that the light bulb will not what? Light up. Look at the second condition. The second condition there is condition 2. Else the light switch could be at on position but no electricity, means that the light bulb will not what? Light up. If the light switch is on and there is no electricity, it then means the light bulb will not what? Come on. So you will always have what? A 0, or you always have what? False. Okay, are we seeing the scenarios? Condition 3. Else the light switch could be at off position but there is electricity, means the light bulb will not light up. That is to say, the light switch is off, is on the off position, but there is electricity. Okay, so there is no way the light bulb will what? Come on. The fourth condition that we are using to demonstrate the AND truth table is that else the light switch could be at off position and this should be and, not but, and there is no electricity, means the light bulb will not what? Light up. That is to say, there is no power supply, the light switch is also off. So these are the 4 conditions that we have. Okay, out of the 4 conditions, the only time that light bulb in your room will light up is when there is electricity supply and the switch that is controlling that light is on the on position. Every other combination, every other condition will always return what? False. That is to say, the light bulb will never come on. That is a typical analogy of a truth table. Okay, if there is power supply is true, condition is met, and if the light switch is on the on position, then the light bulb will what? Come on. If there is electricity supply and the light switch is on the off position, it then means what? The light will never come on. Okay, if there is no electricity supply but the light switch is on the on position, it then means what? The light bulb will not come on. If there is no electricity supply and the light switch is on the off position, the light bulb will never what? Light up. Okay, so this is the concept of what the AND operator would give to you, and there are situations where you need to test for two conditions to be true, then certain actions should be carried out. But if both conditions are not met, then that particular action will not be carried out. So the simplest way you can remember this truth table, it's by using this mathematical concept here, okay, which means 1 times 1 will give you 1, 1 times 0 will give you 0, 0 times 1 will give you 0, 0 times 0 will give you what? 0. So the only time the light bulb will come on is when there is electricity supply and the light switch is on the on position. Okay, if there is electricity and the light switch is on the off position, the light bulb will not light up. If there is no electricity and the light switch is on the on position, the light bulb will not light up. If there is no electricity and the light switch is on the off position, the light bulb will still not what? Light up. Okay, so that is the concept about the AND operator. So if we look at this, let's see, we have two conditions here. If the identifier X, okay, if the content that identifier X is holding is less than the content of the identifier X4, then yes should be printed out. But if it is not, if that condition is not true, then no. Let the user know that their their values are not what? Let the value know that whatever is in identifier X memory location is not less than what is in identifier X4 memory location. So let's test and see what the result will be returned. Okay, so we can see here that no was printed out. It then means this condition returned what? False. Right? It means that the condition returned false. That is to say this or this will still give me what? No. This or this condition will still give me what? No. This or this condition will still give me what? No. Are we together? The only time this will give me 1 is when the value, the expression evaluates to what? True. Okay, so let's go and let's change this operator. Change the operator to less than sign operator rather. So here we are looking at a situation where we want to check we want a situation where yes will be printed out if this result evaluates to true, but if it evaluates to false, then no will be printed out on the screen. So let's look at it again. Okay, so let's see, is the content, the memory content, it printed out no. That is to say that the memory location of X is holding -21 and the memory location of X4 is also holding what? Minus 21. So x, identifier x is not greater than what? X4. Okay, so the result is what? False. So that's why no is what? Printed out. The only time yes will be printed out, let's go to another condition. Let's go to the compound comparison or logical compound relational operator. If we move this, if we do this, so we want to check now. We have two compound relational operator here, so we want to check to say if identifier x is greater than or equal to, we've not done or, so I would want us to suspend this. Let's look at the or operator so that we don't mix things up. So let's go to the or operator or the or truth table. Now the or truth table is this. The or truth table is saying that if the condition on the left hand side is true, or the condition on the right hand side of the or operator is true, the result will be what? True. If the condition on the left hand side of the operator is true, or the condition on the left hand side of the operator is false, the result will still return what? False. If the condition on the left hand side of the operator is false, or the condition on the right hand side of the operator is true, the result will return what? True. If the condition on the left hand side of the or operator is false, or the condition on the left hand side of the or operator, right hand side of the or operator is false, the result will return what? False. Okay, so the only time you're going to get a false result is when both the left and the right hand condition of the or operator are false. Outside that, you will always have what? True. So it's only one condition that needs to be true on the or table, on the or truth table, that will give you what? True. Every other condition, the only time you are going to have a false result is when both conditions of the or operator are false. So we could also see that here. 1 or 1 will give you 1. 1 or 0 will give you 1. 0 or 1 will give you what? 1. 0 or 0 will give you what? 0. Now, it's easier for you to remember this with this mathematical table. The or operator could be likened to the additional sign in mathematics. That is to say, now the condition here, don't forget that we are working the Boolean or the machine language or the logic is using machine what language, which is 0 and 1, and in mathematics that is base 2. And the highest value that you can represent in machine language, okay, or in binary as the case may be. Binary is the machine language that the microprocessor understands, okay, In mathematics, it is called the base 2 numbering system, but in programming, in maths, it's also called my binary. In programming, is called binary. Now, the highest value you can get there is 1. The lowest value you can get in a binary number system is what? 2. Bi means 2. Okay, so binary. Okay, so but the concept here is, look, if you say 1 plus 1, it's 1. 1 plus 0 is what? 1. 0 plus 1 is what? 1. 0 plus 0 will always give you what? 0. We cannot say 1 plus 1 is 2, because in binary numbering system, okay, the highest value you can have in binary numbering system is what? 1. While the lowest value that you can have in binary system is what? 0. So it's between 1 and 0. So you may be thinking 1 plus 1 will give you 2 in mathematics anyway, but in Boolean, in binary operation, 1 plus 1, which is, will give you what? 1. Okay, so just get this concept between, with this, if you can remember this, you will be able to use the OR operator very well. If you can also remember the multiplication table here, that like I did, you will always be able to use the AND operator. Okay, so that's basically the concept behind the AND operator and the OR operator. Okay, so having established this understanding, let's go back to our exercise here, or example rather, that we have been using. So we have now this. We are saying if identifier x is less than or equal to identifier x4, yes should be printed out. Okay, this is what we are, this is what this statement means. This is what the statement means. I'll just comment it out there so that let me comment that so that we will have an understanding of what we are saying. Okay, so this statement here, this is the full meaning of the statement. The condition. The condition here is if identifier x, sorry, change this to this. What this is saying is that if identifier x, okay, is greater than x4, or identifier x is equal to x4, print yes. Now, if identifier, if we remember the truth table of OR, the truth table of OR will give us 1, or 1 will evaluate to what? 1. 1 or 0 will evaluate to what? 1. 1 or 0 or 1 will evaluate to what? 1. 0 or 0 will evaluate to what? 0. So we can see this now. So let's look at, so the only time no will be printed out is when both conditions are what? When both conditions are not met, depending on how the question is and depending on the values that you're using for expression. So I'll just comment this out so that we will flow with it, right? I can get that. Okay, so let's go and see what the result will be. So we know the value of x as minus 21, then we know the value of x4 as minus 21. So if one is correct, if this is correct and this is not correct, it will still print out yes. If this is not correct and this is correct, it will still print out yes. The only time it will print out no is when both are wrong, which is 0 0 or false false. Okay, so we'll go. So we have what? Yes. So it satisfies one of the conditions, and which of the conditions did it satisfy? Is this one. Okay, we could see that indeed x is minus 21, so x is not greater than x4. Okay, because x is minus 21.0 and x4 is minus 21.0. So this aspect of the equation or the comparison returned what? 0. Okay, which is this. Now let's look at this aspect of the equation or the comparison. X is minus 21.0 and x4 is minus 21.0, so they are equal. Okay, and what this operator, this compound relational operator, is saying is that if identifier x is greater or it is equal to x4, print yes. Okay, so that is why it printed x, because it satisfies this other condition, which is this. So if we change this x to x2, okay, and put this as x2, and let's test and see what the result will be. Okay, so if we do this, we still have what? Yes. So we could see now that x2, which is minus 17, is greater than x4, which is what? Minus 21.0. So this side of the equation now is true, which is 1. Then this side of the equation is false, which is what? 0. Okay, and the result still evaluated to what? 1. Right? I was saying it. So we've looked at this condition, we've also looked at this condition, we just looked at this condition, and we looked at what? This condition. Okay, so let's look at the situation where we are going to have a 0 as the result, so that we can print no. Okay, so we have x3, x3. Save and print. So it's going to evaluate, is the identifier x3 value greater than the identifier x4 value? X4 value. If it is yes, keep it. Or is the identifier x3 value equal to the identifier x4 value? Okay, if it is yes, it will still print yes. But if this condition here returns false and this condition here returns false, then our result will be what? No. So let's go and see what we have. Okay, so we now look at it. We say we have -9 -9. Oh, give me a break, please. Sorry, I had to do a changeover. -9, we discover that we still couldn't get no, because -9 is greater than -21. If we are looking at the imaginary numbers to the left of our number system or graph, as the case may be. Okay, so we are done with this operator. Let's look at, if we want to get the no, let's switch the position of x3 and x4. Okay, so we are now saying here that if x4 is greater than x3, okay, or x4 is equal to x3, yes should be printed out. So let's see what the result will evaluate to. If it's going to evaluate to true, which will print yes. If it is false, it's going to print no. So let's go. Okay, so we can now see, all right, that both conditions that we had here returned what? False, false. That is 0 and 0. So we come to this place, the result here, it printed no. We discover that x3 has the value -9.0, okay, and x4 has the value -21.0. Now the condition here is saying, is -21 greater than -9, or is -21 equals to -9? The answer, this evaluated to false, which is 0, and this evaluated to false again, which is also what? 0. So the result at the end of the day is 0, which is why we had what? No. So we could now see that the only time, if you're using an OR operator where you're going to have a false or a 0, it's when both conditions on the left hand side of the compound comparison operator returns what? A 0. Okay, that is when you're going to have what? A 0, and that is when this, our example here, is going to print out what? No. Okay, so this is key. Now let's look at the AND operator, how the AND operator functions. The AND operator, I'm going to introduce I'm going to replicate this. I'm going to replicate this x x2 x2 then x4. Okay, so let's see what we have here. Okay, so I guess this is clear enough, where the whole of this will be seen as, so we have to change this to, let's just replicate the whole of this, copy, we'll change this to and change this to and, change this to and, change this to and. Okay, so we'll now have we'll have 0 0 0 0 0 1. Okay, so the only time yes will be printed out should be when both conditions here are true. Else no should be printed out. That's what we mean by this. So we're going to set this. We say if x4 is greater than or equal to, let's say, let's not use these compound operators anyway, but we can still implement it with that. So we are looking at this now. Is identifier x4 content greater than the identifier x3 content? If it is yes, and the identifier x2 content greater than the identifier x4 content. If both conditions are true, then yes will be printed out. Else, no will be printed out. So let's see what we have there. Okay, so we have what? No as a result. Okay, so we could see no. Okay, because minus 3 x3 is minus 9, so it's then x4 is assigned minus 21.0. So is minus 21.0 greater than minus 9.0? The result is no. And is x2, we didn't evaluate to x2, didn't print out x2. Let me add x2 to, let me add x2 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 x2. So let's take that again. So it's the identifier x4 content greater than the content of the identifier x3, and we have x3 as -9, and we have x4 as -21.0. So it is false. -21.0 is not greater than -9.0. Okay, and -17 is -17 greater than -21. It evaluated to what? Yes. Okay, but remember, the only time that yes will be printed out is when this is true and this other condition here is also what? True, right? Okay, but if one is false and the other is true, we are dealing with the AND operator, so it's always going to return what? False. So no will be printed out because both conditions were not what? Met. From the truth table, the only time yes will be printed out is when what is on the right hand side of the AND operator, left hand side of the AND operator evaluates to true, and what is on the right hand side of the AND operator evaluates to true. That is when yes will be what? Printed out. So this is basically the concept of truth table. If you could understand truth table by that simple mathematical analogy that I stated there, which is the AND operator could be likened to the multiplication operator in mathematics, then the OR operator could be likened to the addition operator in mathematics. That will help you to immediately know the result or the Boolean value in any scenario or condition or situation where you need to evaluate to find out whether something is true or something is false. I'm going to give you a typical example. Let me show us a program that I designed. Okay, I designed a campus CGPA calculator on C#. Okay, let me run it and you see how it evaluates. Now this application is found on Microsoft Store. If you go to Microsoft Store, you're going to see it there. It's an application that I designed and it's online, though it's not free anyway. Okay, so this is the window for first semester. Okay, now I have designed this program in such a way that this text box here, how many courses did you register, can never be 0. Okay, because for every semester you should register at least 1 or more courses. So I have put a constraint here by using the relational operator and the logical operator to put a constraint, a condition here that this particular text box can never be 0 or less than 0, else no calculation will be done here. So if we do this, say how many courses did you register? You said 2. Okay, then you enter the course code, say for example CMS 701. What is the credit load of CMS 701? We'll say for instance is 4 or 5.0. What is the grade that you score there? We say 3.0. Okay, now the next thing you need to do is to click on this add button. Then you'll see the course details here. Okay, so CMS 701, the credit load is 5, the grade point is what, 3. Okay, so you discover that this text box has reduced by 1. Okay, all is behind the scene. The next course you register is CMS 705. The credit load is 4.0. The grade point is 4.0. Then you click on the add button. You have a message, thanks, you can now calculate your grade point average. Tap calculate button below. Click on this. Okay, you now discover that those text boxes have been grayed out, so that the user will not be able to enter any other thing again, because the number of courses that he registered for that semester, which is first semester, 2 courses. Okay, this is to put a constraint on the user not to mess up with the calculation at the end of the day. So you just click, I decided to disable these text boxes. Okay, then the next thing that is available to the user is to calculate this, to calculate his grade point average, which will show up here. So if I click on calculate, his grade point average is 3.44. Okay, then we go to second semester. On second semester page, by default, you have to also register courses. Now, if the user fails to fill this box here first and he does anything, it will prompt invalid operation sequence. Please provide answer to how many courses did you register. Okay, then oops, credit box cannot equal 0 or blank, please fill credit points, as the case may be. If you click any other thing, not until a value has been entered here to indicate the number of courses the person registered for that semester, no operation could be carried out, because you must register a course or courses for a particular semester. So this is also achieved with the AND operator and the relational operator behind the scene. Whatever you do here, whatever button you click, you will always have that, not until you have satisfied the condition before you'll be able to carry out any calculation. So let's say you registered 2 courses again, CMS 711, okay, 4.0, grade point 32.25. okay, we add it, it displays here. CMS 7.712, for instance, these are imaginary, 4.0, 3.0, okay, you add. Okay, thanks. You can now calculate your GPA. Tap the tap calculate button below, close it. So you discover that these boxes are now grayed out, right? So the next thing you need to do is to click on calculate. Now we already have the value we got in first semester. His grade point average in first semester was 3.44, right? Now on second semester, or in second semester, his grade point average is now 2.62. Okay, so we need to do the CGPA, okay, average. That's CGPA, cumulative grade point average. Okay, I click on the average button. Now the cumulative grade point average of that student is 3.03, right? And these are accomplished with decision statements or control decision statements and also logical operators and relational operators. They are all there behind the scene. Programming is quite interesting. Okay, all you need to do is get the fundamentals and the concept, then discover the data type that the programming language you want to use to implement your solution. Next thing is get the syntax in that programming language. The next is to know how to form identifiers or create variable names. Okay, the next thing is know how the logical operators, the arithmetic operators, the relational operators, how they are being implemented, the syntax in that particular programming language. Once these things are there, you should be able to implement a solution on any programming language, as the case may be. Okay, the last thing we are going to look at will be the not operator. The not operator, it's simply this. The not operator is quite unique. There are often situations, there are times where a condition will require you to use the not operator. Now, the not operator simply is this. This is the not truth table. What this simply means is that if you have a true condition, and you not that truth condition, the result will be what? False. If you have a false condition and you not that false condition, false result, and you not that false result, the final result will be what? True. So not 1 will give you what? 0. Not 0 will give you what? 1. That's simply what the not operator will always do. Okay, so let's see if we can implement that here. We have let's see if we can implement that here. We remember that for excuse me. Okay, we're almost 2 hours into this lecture, into this tutorial, so I'll just quickly do this. We remember that this part of the expression evaluated to false, while this one evaluated to true. So if we want this yes to print out, we can introduce, we can use the not operator to force this one to evaluate to true. Okay, so let's see what we have there. Can we now see? Can we see that yes has been printed out? So this result was evaluated, this expression was evaluated to false. Okay, but as we noted it, or as we not it, it was not to true. So we then have true, which returned which returned and printed the word there, yes. Okay, now so that is how the not operator works. There are situations in your designing of program where you might want to use this not. However, I have not had any situation in my programming experiences where I have to use the not operator anyway, but that is what the not operator does. Okay, let's look at what happened here. We could see that we said here the identifier x4, okay, the content of the identifier x4 is it, if it is greater than the identifier x3, okay, if it is greater than the identifier x3, what will be the result? Let's look at the identifier x4 is minus 21. So is 21.0 greater than minus 9.0? The result will be what? False. Now the not immediately change that to what? True, because this and, the only time the and operator is going to return true is when both conditions are what? True. So this was false, the and, the not operator changed it to what? True, and this originally is true, so we now had true, which now printed what? Yes. Okay, so we could see what the not operator did to this other result. It knocked it to the other state, which then turned out to be what? True, and yes was what? Printed out. I hope you take your time and go through this video and get this concept and understanding how these operators are used and how they work. There are situations in your programming experience where it may be required, you know how to implement it to get the actual results that you desire in your programming design, or your program that you're designing. So I'll call this a day. It's over 2 hours. So we'll look at the other aspects, the if, the control statement, and the last video. Thank you.